Today is day 21 of Advent of Cyber 2025. This challenge is called Malware Analysis, Malhare exe. And in our kingdom of Wareville, just like in others, thousands of files of all kinds pass through the systems every day, from docx, PDF resumes received by our elves, to financial spreadsheets, CSVs from the accounting department, and executable files launched by different applications. But have you ever wondered which of these files might be malicious? Which ones could actually belong to King Malhare? An interesting question, isn't it? This task, the TBFC SOC team will investigate one specific file type, the HTA format, type often used for legitimate purposes, yet just as frequently exploited by attackers. The mission is to reverse engineer the HTA and cover how King Malhare tricked Wareville's elves. To do this, you'll have to look for application metadata, script functions, any network calls with encoded data, and clues about exfiltration. And for this challenge, we need to use the attack box, and you can do that right here at the very top, start attack box. And it's giving a warning that although you can do it on your local machine by downloading the task files, you should not actually execute them at all. It should only be used for analysis. HTA overview. Not long ago, in the summer of 2025, researchers discovered that ransomware groups were using HTML files disguised as fake verification pages spread the Epsilon Red ransomware. During the campaign, many organizations were affected. Security teams were reminded how important it is to understand what HTML files are, why they appear so often in corporate environments. So, what exactly are HTML files? Why do they exist? In Wareville's digital kingdom, not every strange-looking file is a threat. Some were originally created to make the daily work of developers and administrators easier. One such helpful invention is the HTA file, short for HTML application. HTA file is like a small desktop app built using familiar web technologies such as HTML, CSS, and JavaScript. Unlike regular web pages open inside a browser, HTA files run directly on Windows through a built-in component called Microsoft HTML Application Host, mshta.exe. This allows them to look and behave like lightweight programs with their own interfaces and actions. In legitimate use cases, HTA files serve several practical purposes in Wareville and beyond: automating administrative or setup tasks, providing quick interfaces for internal scripts, testing small prototypes without building full software, offering lightweight IT support utilities for daily use. In short, HTA files were designed as a convenient way to blend the simplicity of the web with the power of desktop applications, a tool that many TBFC engineers and elves still use to keep SOC operations running smoothly. HTA file structure. Before the defenders of TBFC can recognize suspicious HTA files, it's important to understand how a small HTA file is built. Luckily, this structure is quite simple. In fact, it's very similar to a regular HTML page. An HTA file usually contains three main parts. HTA declaration. This defines the file as HTML application and can include basic properties like title, window size, behavior. The interface, which is HTML CSS. Section creates the layout and visuals such as buttons, forms, or text. And the script, Visual Basic Script or JavaScript. Here is where the logic lives. It defines what actions the HTA will perform when opened or when a user interacts with it. In this one, you see got the HTML, but then there's this HTA application declaration right here. This small example creates a simple desktop window button that shows a message when clicked. In real cases, HTA scripts can be much longer and perform important tasks. Easy to see why developers like HTA. You could build a quick, functional tool using nothing more than web code. However, as TBFC's defenders will soon learn, the same flexibility that makes HTA convenient also makes it powerful enough to require careful attention. How King Malhare turns HTAs into weapons. HTA files are attractive because they combine familiar web markup with script executions on Windows. In the hands of a defender, a handy automation tool. In the hands of someone wanting to bypass controls, they can be used as a delivery mechanism or launcher. The HTA files are often delivered by phishing, email attachments, fake web pages, downloads, and run via mshta.exe. An HTA file can execute a script that fetches additional binaries or scripts from the attacker's C2. HTAs can hide intent by embedding encrypted data with base64, by using short BBScript or JScript fragments, or by launching processes with hidden windows. And HTA commonly calls built-in Windows tools mshta, PowerShell, WScript, RunDLL32 to avoid adding new binaries to disk. Inside an HTA, you'll often find a small script that may be obfuscated or encoded. In practice, this tiny script usually does one or two things: downloads and runs a second stage payload, or opens a remote control channel to let something else talk back to the attacker's server. These lightweight scripts are the reason HTAs are effective launchers. Small file can pull in the rest of the malware. Here's the sample that King Malhare might try to use. So we've got the script here in VBScript, and we can see we've got this base 64 right here, which is then being converted to string, and that value is being used in PowerShell, and it's executing that string as a command. As you can see, this HTA is very different from the simple example that we provided earlier. It contains a number of obscure elements that deserve a closer look. Let's walk through it. In analyzing HTA's title and HTA application tags often reveal how attackers disguise malicious apps. Might use a convincing name like salary survey or internal tool to appear safe. Always check these first. Secondly, there's a VBScript block marked with the script language VBScript. That's the active part of the file where attackers often embed encoded commands or call external resources. Inside this block, we find a PowerShell command. Like this PowerShell no profile execution bypass command. Pattern commonly seen in malicious HTAs used for delivery or launching. The PowerShell invocation contains a base 64 encoded blob from base 64 string. This is likely a pointer to further instructions or a downloaded payload. See an encoded string, assume it hides a URL. Decoding it reveals the attacker's command and control address or a resource used in the attack. Always decode before assuming what it does. Malware authors often use multiple layers of encoding and encryption, such as base 64 for obfuscation, as some form of encryption, or cipher to conceal the true payload. When you decode the base 64, check whether the output still looks like gibberish. If so, a second decryption step is needed. For analysis, will extract that base 64 code and inspect it with a tool like CyberChef to reveal what it hides. So in this example, they've put the base 64 string in, and you have set up the recipe to convert it from base 64, and we can see that it is retrieving raw.king-malhare.com in the C2 server. Now, in the example, we've redacted the remote resource and replaced the real link with the redacted.txt file for safety. In a real incident, that string would usually point directly to a file hosted on the attacker's C2. After the encoded PowerShell command, we can see three key variables, $U, $C, and $B. Let's quickly break down what each does. $U holds the decoded URL, location from which the next script or payload will be fetched. $C contains the content downloaded from the URL, usually a PowerShell script or text instructions, and $B converts that content into an executable script block and runs directly in memory. Whenever you see a chain of variables like this, try to trace where each one is created, used, and passed. If a variable ends up inside a function, like run, execute, or eval, that's a sign that downloaded data is being executed, key indicator of malicious activity. As a summary, the process for reviewing a suspicious HTA can be broken down into three main steps. Identify the script section, look for encoded data or external connections, and follow the logic to see what's executed or being sent out. So we reviewed how attackers might use an HTA file for malicious purposes, and now that you've seen how HTAs can combine HTML, VBScript, and PowerShell, you apply the same processes to analyze a suspicious one. Start by locating script sections, then identify functions, encoded strings, any references to URLs or system calls. They create anything that looks like it is hiding information, and trace how the script uses the results. So now it's our turn. So for me, the attack box was failing to start, so I will need to go here and download the task files. And for safety, just to make sure I don't accidentally execute it, I'm going to rename it to be just.txt. That will prevent me from accidentally clicking and running it. I'm going to open up VS Code. We can see the raw content, and we can see it here now. Okay, so we've got it open here. But we'll start by analyzing metadata of the HTA. Will tell us what purposes it is telling users it has. So right here, HTA, it's saying it's a festival elf survey, and its title is Best Festival Company Developers Survey. Next, we will want to understand what the HTA actually does. This means we need to search for the VBA script section. For function definitions, we need to look for any lines that start with the function or sub in our HTA. See 5 functions, namely window unload, get questions, provide feedback, code base 64, and RS binary to string. So within these functions, we want to understand any real actions being performed. These are usually denoted by a create object, our application containing a couple such as Internet Explorer application, WScript network, and WScript shell. Lastly, we want to understand what the HTA actually looks like for the user. Here it is very similar to HTML files. To do this, we need to take a look at the body, starting on line 169, and This is the part that will actually be shown to the user. So let's get on with the questions. What is the title of the HTA? That is Best Festival Company Developer Survey. What VB script functions acting as if it is downloading the survey questions? That is Get Questions. What URL domain is the questions being downloaded from? That is survey.bestfestivalcompany.com. But there's two I's in the Best Festival company name. Malhare seems to be using typo-squatting, domains that look the same as the real one, in an attempt to hide the fact that the domain is not intended. What character in the domain gives this away? That is two I's there, so I. Malicious HTAs often include real-looking data, like survey questions, to make the file seem authentic. How many questions does the survey have? I don't know if it wants us to actually go to it. What I'm thinking is maybe in the HTML. Yes, there's 1, 2, 3, 4 in the HTML. Notice how even in code, social engineering persists. Fake incentives like contests or trips hide in plain sight to build trust. The survey entices participation by promising a chance to win a trip to where? So we can see right here, there's been a trip to the South Pole. So South Pole. The HTA is enumerating information from the local host executing the application. What two pieces of information about the computer it is running on are being exfiltrated? Should provide the object name separated by commas. So let's go back here, and we can see with the provide feedback section, there is computer name and username. So computer name and username. What endpoint is the enumerated data being exfiltrated to? That is this. So /details. What HTTP method is being used to exfiltrate the data? Let's take a closer look. Doesn't appear to be specifying HTTP type method. It's probably safe to assume it's get. See that? Yeah. After reviewing the function intended to get survey questions, it seems that the data from the download of the questions is actually being executed. What is the line of code that executes the contents of the download? Let's see, we've got, so this is running, I navigate to wild, then we've got the result and being decoded, then it goes to provide string, got decoded string, that's feedback string, and that would be this one right here, run object PowerShell exe. It seems as if the malware site has been taken down, so we cannot download the contents that the malware was executing. Fortunately, one of the elves created a copy when the site was still active. Download the contents from here. What popular encoding scheme was used in an attempt to obfuscate the download? Probably safe to assume it's base 64. It now wants us to decode the content. So put base 64 here, then from base 64. And it seems as if the additional steps were when taken to hide the malware. What common encryption scheme was used in the script? The script has data in as well. Let me just make this full screen so I can actually see what's going on. So I've got this function. I think this is rot13. Let me try that. Grab the flag. We can tell it's a flag because of the format it's in. And since we can see it's got a consistent format, it probably is rot13. 13, get rid of you. And we can see thm malware.analyze. So go back to the questions. Rot13. And then we can put the flag into here, and that is all the questions answered. So that's day 21 of Advent of Cyber 2025 complete. Like this video, make sure to